Greetings, everybody. My name is Kevin Soto Cedeño. I am 23 years old. I am in my sixth year of college in the University of Puerto Rico at Calle, and now I'm going to present you my little report about COVID-19, the cause of the longest lockdown recorded in Puerto Rico. As introduction, throughout history, multiple quarantines have been registered to contain the spread of lethal diseases. As example, we got the Black Death and the Spanish flu. So now, in the 21st century, we have relieved the uncertainty of the spread of new disease that led the world once again to quarantine. In this case, is COVID-19, which is caused by SARS-CoV-2 virus. Everybody knows what COVID-19 is, but the problem with this virus is that in some cases the respiratory system is affected, and in the worst case, these people going to die. So, for this report, we select Caguas, Puerto Rico to investigate the behavior of the virus spreading because it's a small place in a period of 6 months. So here we got an image of Puerto Rico, and the town in red is Caguas, with a population of 131,363 people. So materials and methods. We use the statistical data collected by Johns Hopkins University in a specific daily positive case register. To analyze this data, we use our statistical program, and we want to compare this variable, daily positive cases register, with other variable and find a relationship. So we select the community mobility report made by Google and the temperature reported by National Oceanic Atmospheric Administration, better known as NOAA. The data was limited to the period between June 16, 2020, when lockdowns were more flexible, to December 21, 2020, where lockdowns had more restrictions. So we submit all this data in the R program and we get the next result. Here we got our first chart with the title Daily New Cases versus Dates. So in this first chart, we show the report of new positive daily cases registered in Caguas. As mentioned in the previous slide, data was selected as of June 16, 2020 because at the time of the lockdown were less restricted. During this lockdown, restaurants housed more than 50% capacity, bars were opening, people could go to the shopping, to the beach, to the gym, etc. That's what we call a less restrictive lockdown. So, when new cases were rarely reported at the beginning, now there are new cases begun to report every day, and sadly, more each day. So then the government changed the executive order, and now we cannot go to the gym, we cannot go to the beach, we cannot go to the mall, etc. And the case started to decrease. But then the government again changed the executive order and the case started to increase and then again and again and again, like again. So that's why we can observe a wave behavior in this graph. So here in this table, we can observe all the changes in the executive order. As we can see, were 9 changes in 6 months. In other words, a lot of changes. So here we got our second chart with the title Positive Case Report versus Date. In this second chart, we present the accumulation of the case register in Caguas. As we can see, there are more than 3,000 infected in this town. So this is sad because at the beginning, 0 cases were registered each day, and now every day new cases are registered. The third chart presents the data of daily positive cases and compare it with the community mobility report of different places where people usually go, such as workplace, park, residence, and pharmacy grocery store. They were used to determine if there was any relationship with the spread of the restriction imposed to these places. Each place has been colored for better understanding. To be able to perform the analysis, the data was normalized. After creating the graph, no relationship with community mobility report and case registration was observed. However, the number of cases continued to increase, so it can be assumed that the virus can be contracted in any of these places. Finally, the four charts show the data of daily case in comparison to the temperature of the atmosphere and the air on Caguas. To be able to compare them, the data was again normalized. An inversely proportional relationship between temperature, both air and dew point, with the incidence of daily cases could be found. In other words, when one increased, the other decreased. If so, it can be inferred that later, when the temperature increases, the case of COVID-19 will decrease. Of course, the increase in this case may also be due to other factors such as the election, Thanksgiving, Christmas, etc. In addition, the temperatures always decrease in winter, including the Caribbean, so this relationship is not necessarily correct. In conclusion, the Covid-19 cases report on Caguas continues to be a concern for the mayor and its citizens. After the result reported, it can be recommended that the lockdown must continue to be respected. There is no relationship with community mobility report and the virus, chart number 3, or at least on the town selected, in this case, Caguas. And there is an inversely proportional relationship between temperature and the virus, chart number 4. After concluding this report, the recommendation will be to repeat the study once again in a few months. By repeating it now that the vaccine is being distributed, the researcher can get a better scope of how successful it really is. This study is conducted during an online coding bootcamp supported by MSF and the University of Tennessee at Chattanooga. Those are my reference and thank you for your attention. Be safe.